Hi coders, today we'll solve two binary search problems. In the first one, we'll apply binary search on the indices of the array, while in the second one, we'll apply binary search on a number range. The first problem is problem 704, binary search on LeetCode. I'm discussing this problem for two reasons. First, to familiarize with how to apply the template. Second, if we know how to search for a target element in a sorted array of known size, it will form basis for an important question that we'll discuss in the following video, where we need to search for a target in a sorted array of unknown size. As I mentioned earlier, we will be using templates to solve problems. Here we will use template 1. I have added the link to the template in the description. In this problem, we are given a nums array which is sorted in increasing order and a target element. So the nums and the target are the input parameters. The aim of the problem is to search for the target element in the nums array. If the target exists, then we need to return the index at which it is located, otherwise we will return -1. We need to write the algorithm in log n time complexity, and we know we can achieve this logarithmic complexity using binary search. Let's see what changes we need to make in template 1. Here the low points to the 0th index, that is the start of the array, and high points to array.size -1, that is the end of the array. This range is good because this is where we need to search for the target element. Next, we need to add a search condition. If the middle element is equal to the target, then we need to return the middle element, and we are done. The else if block here is to shift the search range to the left, and we need to shift our search range to the left if the middle element exceeds the target, that is, all the elements to the right of the middle element would be greater than the middle element, and since we have already checked the middle element, the new range would be low to mid -1. By the same logic, if the middle element is less than the target, we'll shift our search range to the right. This scenario is handled by the else block. By default, if we did not find the element, we have to return -1 as mentioned in the question. I have written the code that we discussed. So let's try to submit it. So this works. I have added the code link in the description. Now that we are done with our first problem, let's solve our second problem. Problem number 374, guess number higher or lower on LeetCode. The game that we are playing is a guessing game. We pick a number from 1 to n and we need to guess that number. Every time we guess a number wrong, we will be told if the guessed number is higher or lower than the picked number. This information will be provided by a guess function call, which can return -1, 1 and 0. -1 if the guessed number is greater than the picked number, 1 if guessed number is lower than the picked number, and 0 if the guessed number is equal to the picked number, and we need to return the picked number. One way to solve this problem is by doing a linear scan for all values 1 by 1 from 1 to n and check if the guess function call for that value is equal to 0. If it is, then we got the answer and we need to return that. But note that we are wasting the information here. We don't care if that number is higher or lower than the picked number. We only care if it's equal to the picked number. That is -1 and 1 are equivalent. If you recall the first question in which we used binary search template 1 to search for a target element in an array and use that target value to shift ranges either to the left or to the right, doesn't the pick number here look like the target? It's just that the target is hidden. But please note that the comparison result with the target can be determined using the guess function returned values, that is -1, 1 and 0, enabling us to alter our search ranges. If we think about the range on which we can apply binary search, the answer value can be among 1 to n, which is a monotonically increasing number set. So we can take 1 to n as the range and apply binary search on it. Let's try to alter our template 1. As you can see, the input parameter is n here. Return type is here int. Since the range is from 1 to n, low will point to 1 and high would point to n. Let's make our guess API call on the mid. So we can reject half of the range if the target, that is a picked element, is not equal to the mid. I have stored guess function call result in res variable. If res is equal to 0, guess number is equal to the picked number, that is mid is equal to the picked number, and we can return mid. So this block is handled. The else if block will shift our search range to the left. We need to shift our search range to the left of the middle element when mid is greater than the target. That is, guess number is greater than the picked number, which happen when res is equal to -1. So the search condition here would be res is equal to -1. And here it would be res is equal to 0. So this is done. In the else block, we'll shift our search range to the right if the mid is less than the target, that is the guessed number is less than the picked number. We can see that happens when res is equal to 1. There are only 3 values that res variable can take: 0, 1 and -1. We have already covered 0 and -1. So we can use a else block here. We don't need to use a else if block. By default, we can return any value other than 1 to n. I'm returning here -1 by default. Ideally, the control should not come here because we are given that the number is picked from 1 to n. And control will reach here only when no number is picked from 1 to n. I have written the code that we discussed. Let's try to submit it. So it works. I have added the code link in the description. That's all for this video. The following video will solve a binary search problem on a sorted array with unknown boundaries. Thank you.